Shall I do the introduction?
No, that's fine. If you do the introduction, over to you.
Okay, good morning. Welcome to another CWS seminar. It's great to see so many of you here. It's my great pleasure to welcome Jeremy Heath today to give a talk for us. He's got more than 30 years experience in the water industry. He's responsible for the management of innovation within SES. He has keen interest in innovations that will transform how we manage our water networks, in particular smart metering, smart networks, artificial intelligence, and IoT communications. In addition to his role as at SES Water, Jeremy is also the head of UKWIR National Zero Leakage project and is responsible for drinking and driving the UK leakage research program. Thank you very much for accepting our invitation. Over to you. There will be opportunity for some questions at the end of the talk. Thank you.
Thank you, and it's really lovely to be here. I understand this is the engineering building, correct? Yeah, fantastic. Really nice being back in the engineering building. I am a mechanical engineer by background, also a programmer, but as you heard, I've been 30 years in the water industry or more for my sins. I've obviously done a lot of wrong stuff to be that long in the water industry. So, look, I'm going to be talking about the use of innovation and how we're going to be trying to halve water leakage by using that. And I want to start off by actually discussing, the actual kind of scale of the problem here. A quick overview of the UK. Okay, so number one is just understand that we use what's called a bottom-up calculation to work out leakage. That means that instead of, come on in, grab a seat, there we go. Instead of working out leakage by saying this is how much water we put into supply and this is how much is taken out, we struggle to do that in the UK because we don't have 100% metering on all of our customers. So therefore, when we started doing leakage back in the 80s, we had to come up with another way of doing it. And we said, okay, what we do is we monitor areas and we look at the night line. We look at how much water is being used at 3 o'clock in the morning. And we use that and we say, okay, that water use at 3 o'clock in the morning, some of that will be usage and some of that will be leakage. And we make estimates and we base it upon that. Do that across enough areas, round it all up, and you have a leakage figure for your calculation. And then what we do is on an annual basis, well, in fact we do it more frequently these days, but you do a reconciliation. We go, okay, let's do a top-down full water balance, all the water going into supply where we think it's going, balance it up with our leakage at the bottom, the two should match up. Okay? In the UK, almost every company will have full DMA coverage, so a district meter area, DMA, typically about 1,000 properties in every DMA. And we have, as part of our reporting, we report losses on the customer side. And this is the big difference. When you talk about international comparisons, typically they talk about non-revenue water. So as soon as water is charged for, as far as they're concerned, that's not their issue. What we have in the UK, because we came up with this bottom-up method of doing leakage, where we said, okay, look, we're measuring all the leakage that's occurring. We don't know whether it's on our pipes or it's on the customer side, because it's happening at 3 o'clock in the morning. So we actually record customer side leakage as well. And that can be on their supply pipe, the pipe going into the building, but actually loads of it we know is going on toilets and things like that. So what we call plumbing losses inside the house as well. So that's included in our leakage figure. And we estimate that that's typically about 25 to 30%, 35% of our leakage is actually on the customer side. It's one of the kind of messages we've got to get through in the UK with our press, who talk about all the company pipes are leaking. Every time you see those figures in the UK press, you can kind of take a third off, because actually our company pipes are about 2/3 of that, and about 1/3 of that is going to be customer side leakage. So typical figures you'll find in the UK, 8.7 metre cube per kilometre per day, 113 litres per property per day. That allows you to do some international comparisons. I really don't like percentages for leakage. The reason I don't like them is because if you imagine I've got 100 megalitres going into an area a day and my leakage is 10 megalitres, yeah, you're going to say that's 10%. But if I double my consumption, if I say to everybody start using twice as much water, I've got 200 megalitres going into the area, still only 10% leakage. I've halved my leakage figure by simply doubling consumption. It's why we don't like using percentages. But if we're going to do it that way, for my company, we're leaking from our pipes about 8%. Okay, so again, you're mentally doing that figure and going, okay, with 1/3 overall total leakage, 12 to 13% within my company area, but our pipe's about 8% leakage. Okay, what's the problem though? So I've told you that we've got a halve leakage. Why? The reason is this slide. This has come out from the National Infrastructure Audit 2. Okay, catchy title. National Infrastructure Audit 1 got a lot of sales, but obviously they really felt they needed to go for it with the second and the sequel. National Infrastructure Audit 2 came out from the National Infrastructure Commission. Their job is to look at all infrastructure across the UK and say, is it fit for purpose, and what is it going to be like in the future? Are we investing correctly in our infrastructure? And when they looked at water, this is the slide that they put up for that. They said by 2050, the estimated supply gap in the UK is 4,000 megalitres per day. That's the gap between how much water we have and how much water we need. They have since revised that figure and said, oh, do you know what, we think we actually got that wrong. They revised it up. They now believe it's 4,800 megalitres a day. To put that in context, that's the entire distribution input, all of the water that's supplied daily by Thames, Severn Trent and Anglian put together. The reason for that is because demand is going to go up, more population, more usage and everything like that, and at the same time, our availability of water, because of climate change, is going to go down. So we are going to be missing nearly 5,000 megalitres a day in 25 years. Infrastructure Commission said there's 3 ways we'll deal with that. Number 1 is storage and move the water around. And you always hear about this. People go, oh, it's wet in that area. Why don't we just move the water? Moving water is expensive. A cubic metre of water is a tonne. If you wanted to bring that down from Scotland and you put it in the back of your car's not going to last very long carrying a tonne of water. Moving water is expensive to do, but we are putting in transfer schemes to do that. Okay? So you're seeing new reservoirs being built and some massive transfer schemes now being built in order to manage that. That will give us about 1/3 of that. At the bottom, reduced demand. That's you, me and everybody just using less water. And what we need to do is just reduce our consumption. That will be smart metering and all the tools that you're seeing coming through in that area. And then finally, in the middle there, halving leakage. 1/3 of it will come through halving leakage. And unless we actually get that leakage down, we're not going to meet that supply-demand deficit. I always say, look, halving leakage in the UK has gone beyond being reputational for the companies. It's gone beyond being a regulatory issue for the government and for those bodies. It's now a requirement. Because unless we actually manage to halve leakage, my kids, grandkids, whatever comes along, your kids are going to be turning around and going, why is there water rationing? Why do I not have water like when you were growing up? How come when you were growing up you could just go in the shower and use it as long as you like, and I have to have a ration, a certain amount of time I can use it for? Because unless we solve that, the UK is not going to have enough water to go around. So there's no do-nothing option here. We've got to solve that issue. Okay, so let's halve leakage, because, hey, let's face it, that's easy. Lots of other countries have actually halved their leakage, and they've done it very successfully. That's our leakage trajectory going forward. So we baseline at 2018 as an industry. We're saying that's where we've got to drive it down to, and you can see it nicely dropping over to the right as it goes down. And you go, well, that's a funny graph because it's got that great big kink in the middle of it. Why on earth does it look like that? Well, that's because that's the average reduction up to date so far and the trajectory going forward. Because we've got up to 2023. We've now got to really push it down even more. And the reason is, if I plot every single water company's leakage figure on there, that's what I'm getting. Why are they going up? Because it's hard. This is not going to be easy. And a number of water companies are actually struggling to drive down their leakage at the moment. And it's not for lack of trying. It's not for lack of experience. They've got good people in there who know what they're doing. But this is really, really not easy to do. And they're struggling to manage it. And so what we're doing is going, okay, look, in order to solve leakage, you need to bring in a multitude of tools. The danger comes is that everybody thinks there is one silver bullet that will solve leakage, one solution. You just put that in and that's going to solve leakage. There isn't. So we coined this phrase PALM, prevent, aware, locate and mend. You want to solve leakage, you've got to do all 4 of those brilliantly. Okay? So When we look at prevent, we're looking at asset renewal, changing our pipes, finding the leaky old ones. When we look at pressure management, we're looking at network calming, stop all the pressure waves going through our systems and causing bursts. We look at awareness, let's understand where leakage is breaking out. If we can't stop it, let's at least know where it is. That's about dividing your network up into areas so you know where the leakage is occurring. It's about understanding, is the leakage occurring on my trunk mains? Is it on my distribution mains? Is it on the supply pipes? Is it within the customer's properties? Be aware of where that leakage is, and that's about DMA management, data consistency, flow analysis, all of those bits. Fine, we now know that leakage is occurring in this area or on these types of assets. We then have to locate it. So you've got to go out there and say, okay, active leakage control, literally feet on the ground, going around, listening on fittings, trying to find the leakage. Acoustic correlation, so devices that are going out and correlating that leak and saying, it's louder here, quieter here, that means it's further towards this fitting. And then non-acoustic methods, and we're seeing a rise in those. Satellite solutions, fibre detection, all of these methods that are coming in that help us localise that leak and say, here's where it is. And then finally, we've got to be able to repair it, mend. It's the area that's most overlooked, actually. And most of our repairs, in fact, almost every repair you'll see is done by digging a hole. Okay? We dig a hole, dig down to the pipe, and then we'll either cut it or clamp it. Although some of the new techniques that we're starting to look at are keyhole repairs and no-dig methods, and that's where we're really starting to push it to try and bring those in as well. But there is no silver bullet, and those of you who are thinking about going into the water industry and want to work in leakage, recognise this. You will help solve one of those areas. You will work in one of those areas and try and drive understanding in that area. But there is no one solution that will solve leakage. So, where does that lead to? So this is the research programme that I lead in the UK. So UKWIR is UK Water Industry Research. It's an industry body funded by all of the water companies. So I manage this programme. The blues are projects that we have completed. The greens are currently live ones. The orange ones are just actually coming live. In fact, these ones have just started over there, and I've got some other ones just coming through now. It is a busy research programme. I've got somewhere in the region of 10, 11 live research projects at the moment. I've got 15, 16 completed. We have a load of research that's going on across the UK. And this is fundamental research, trying to understand mechanisms. I have PhDs working on understanding what's the failure mechanisms of the cast iron, how do cracks develop and grow. I've got other work going into acoustics. How do we make sure that we get the best value out of all the sound that's coming out? I've got research projects where I've got a consultant in and I've said, look at all of the metering data and say, if I've got all of the smart meter data for an area and I know the flow going in, can I balance the two up and understand what's going on in that area better? So there's a whole host of research that's going on in that area. But as I said, this is generally fundamental research. What we've also got is other stuff as well. You see, the great news is the water companies collaborate almost completely on water leakage. Okay? It's nice. We don't get benchmarked against one another. I showed you that graph with all of the different companies. There's no financial disincentive for me to share my expertise with other water companies. Although we are monopolies in terms of how we operate, we are encouraged to share and collaborate. We fund joint research, but we also share the results from our own projects. Each company will have their own little projects that they're working on. And what we've done is we've actually put that all together into something called the Leakage Innovation Heat Map, which is almost unique, certainly in the UK, as far as I'm aware, worldwide as well, where we map out all of the research that's happening in leakage in the UK at the moment. You can actually download it. It's publicly available. It's on the UKWIR website. You can go to that site and you can actually pick up this project list. It will give you 420 projects within companies, either recently completed or live at the moment, or even ideas that I'd like to solve, saying these are the problems that we're looking at the moment. What I've also put on that heat map as well is all the shared innovation fund projects. Ofwat have got a massive innovation fund that we can pull upon, and I put all of the ones that relate to leakage are on that list as well. The UKWIR projects, links to the actual projects are on there as well, so you can actually download and read those studies that we've done, and Spring showcases. Spring is the innovation platform for the water companies, and you'll find a number of showcases on there about various solutions that people have shared. So there's a wealth of information. The idea of this was to be a one-stop shop you could go to and find out what is going on in leakage at the moment in the UK. So the kind of details you get, company projects, as I said, nearly 420 in total. It will give you what the project is, broken down by project type. So the green are prevent ones, then you've got aware ones, but even within that we break it down by sub-areas as well. So if you want to look at supply pipe replacement projects, all of those ones you can see there are related to that at the top. And you can see it by the company and what they're working on. It allows us to then start to say, okay, how much research is occurring in different areas? And this is what we found, is that 18% of all of our projects are actually in prevent. Nearly 70% are in awareness location, and poor old MEND, as I said, 11% there. And if you look at the live projects, it's a similar view as well. Most of the research taking place in that awareness and location area, but very, very little in prevent, and hardly any in MEND. Part of the reason behind that is how our companies are structured. You see, if you look at it, our leakage managers have control of awareness and location. So they have the software solutions dialing out, bringing in the information of what's going on out there, and they control the teams that go out looking for the leaks. So therefore it's quite natural. Those are the bits that they can control. Typically prevent will be managed by another department because it's the department that actually manages the network. They open and close valves. They're about network pressures and about network calming, and they tend to deal with the network replacement as well. So though the leakage managers have influence there, they tend not to control that area. MEND is even worse because, of course, with MEND solutions, typically it's some poor old contractor who's just given a bucket of work and then kicked and said, keep the work in progress down as low as you possibly can. And that's about it. So we're trying to redress that balance. What was really interesting is our regulator said, okay, I want you to return your costing information for PR24. I want you to do that by palm. So our regulator adopted exactly that same method and said, break down your costs by palm. And the whopping great big surprise is 52% of our spend is repairing the pipe. When we did this for the first time, the leakage manager, oh, wow, I never really realised that, because no, they don't see those costs. That's another department. But that's our huge discrepancy. 13% of innovation, 52% of spend is on MEND. So, where do we go? Let me work my way through in those various areas. So let's start off with prevent. So massive mains replacement is really hard to justify in the UK. One of the things I said is, yeah, surely driving down leakage is really easy. You look at Tokyo. Tokyo typically has 3% leakage. Now the reason for Tokyo having 3% leakage is because they very, very nearly ran out of water during the Olympics back in the 60s. It was very, very close. And they realised that their network was very old and very leaky, and so they changed every pipe. Literally went into Tokyo, dug up every road, replaced every single pipe, and they put in stainless steel supply pipes as well at the same time. All of the joints are locking joints. Tokyo obviously being near an earthquake zone as well, there's a tendency for the ground to move, and so every joint locks in on the one behind it, and so it's a very tight system. So yes, if you can replace every pipe, it's simple, but we can't do that. And now, actually, the cost of doing that in the UK is astronomical. I was looking at a scheme recently in Thames Water, published details on the internet, so I'm not giving away any information here, but they were replacing 1 mile of pipe in Mile End Road. The budget cost for doing that was £20 million. Now, it doesn't cost £20 million to put a pipe down the road. The reason for those additional costs is all of the disruption. Is all of the social factors as well, the local businesses who are going to lose business and put in claims, is all the other bits that go in that. So the cost of replacing our pipes now is so high that it's really hard for us to justify in terms of driving down leakage. In addition, in the UK, we have a 3-hour interruptions to supply measure. And that says, okay, you're only allowed to turn water off for 3 hours. Now that's almost unique. I'm not aware of anywhere else in the world that really has that measure. And what that means is that any solution to replace the pipe, which uses the existing pipe, so that's if you're going to slip line down a pipe, draw another pipe down the old one. If you're going to reline a pipe, either using a structural or semi-structural liner, and you've got to use a dry pipe to do that, you've got to drain it out. All of those methods are really difficult to use within the UK. So it makes lower cost replacement almost impossible at the moment. And the problem that we've got is our system's increasingly aged and needs replacement. What we do need is a good understanding of acid condition. So we know that we have loads of cast iron still out there, 40–50%. But what condition is that in? It's buried 1 metre below ground. So what we're trying to do is build our understanding of how that fails and what's the current condition of that asset. One of the pieces of work I've been doing is effectively using a Canadian technology that uses a sound pulse. You remember, no, I'm not going to say you remember because none of you are that age, but in the old days what they used to do is when they had a steam engine and they wanted to check the integrity of the wheels is they would walk along with a hammer and go bang and bang the hammer against the wheel. And if it went bang with a nice loud ding, it was good. And if it went dunk, you'd know there was something up with it simply by the sound it made. Because the speed of sound changes as it goes through different materials. So, by using the speed of sound passing down cast iron mains, we can tell the condition of it. And we started surveying our mains to do that within my company. We've surveyed well over 500 kilometres of main. That's the results that you can see there. So, I've done this by decades. So you have it from 1860 over on here going all the way up to modern decades over there. And what we can start to see straight away is that we have good pipe, moderate and then poor. I know within SES that about 6% of our main is in poor condition. The beauty of this is I can now go back and test those mains in a 5-year interval and I can actually see degradation occurring and start to understand that. But that's easier for my company because we're small. I can do that within my area because we're only covering 300,000 properties just south of London. Thames, Severn Trent, Anglian, if they tried to do programmes like that, it would take them an awful lot longer to do. So therefore, one of the things we do need to do is gain understanding of what is our current condition of assets and how are they deteriorating underground. It's not even as simple as saying our older pipes leak more. So one of the things that's now published is the data sets for all of the water companies. In fact, you can go on something called Stream Open Data, and you can download data sets for all of the water companies, and I did that. So I downloaded every water company's data set, and one of the bits of information they have on there is how much main they've got pre-1960s. So I said, okay, let's do a simple correlation. I can see your leakage figure from your data sets, and I can see how much main you got pre-1960s. Let's put a little experiment up there. My view would be is that if you've got newer mains, they should leak less. However, what I find is that as I have my older networks going up and my higher leakage going to the right, I actually have a slightly negative correlation. Now, I will admit I took Thames out of the picture. They are a bit of an outlier in the leakage industry. But that's slightly concerning. Why am I laying new pipe and it's still leaking? In fact, in many ways, it appears to be leaking more. Part of that is because since 1960, we've had 3 new materials introduced. We've had ductile iron, PVC, and polyethylene. As each new material came in, there was a learning process on how to use it effectively. Ductile iron came in, and we just threw it in the ground, and then only about 10-15 years later realised that it corrodes faster than cast iron, and we need to wrap it. And you now start to see all sorts of layers over the ductile iron in order to protect it. PVC came in, and that was it within, well, I was laying PVC when I first started. PVC coming in, and everybody, it's a wonder material. You just throw it in the ground, and it goes round corners with a crowbar. Yeah, you just bend it to get it into the trench. No, you can't. What you've done is put a stress riser on the outside of that pipe. In addition, you can't leave it by the side of the road in the sunlight because the UV will degrade the PVC, and so 15 years later it bursts. So unfortunately, PVC causes problems. And then PE came in and we said, what a wonderful material. PE, we can bend it all over the place, fantastic. Can we join it? No. I can see shaking of heads around the room. Joining PE remains really difficult to do. Okay? Joining PE because every time we're doing fittings, we do them in the lab and it works absolutely perfectly. And then we take it out onto site where effectively what you're going to be doing is melting plastic and pushing it together, and suddenly we're on a site that is dirty, wet and muddy, and it doesn't join so well. And it may get a joint at that point that holds pressure, but a year down the line, suddenly that joint fails. So we struggle with these materials as they come in. We need to make sure that as we introduce these materials, and the training materials are there to make sure that they don't leak in terms of what we're doing there. What we are seeing is some good solutions coming through using previous failure data, and that's starting to predict our asset condition and saying this is where we're going to see problems. I wanted to touch upon pressure management as well. Pressure reduction is a vital tool in reducing leakage. We've got a project at the moment called DMA Asset Health, and that's probably state of the art in the UK. We have the most pressure managed number of properties in the country, 80% of our properties are under pressure management. It has a dual benefit. It reduces leakage rates, but it also reduces consumption. However, some of the latest research I'm seeing is suggesting that as you reduce the pressure, you will get a short-term benefit, but it may not be there long-term. Okay? That your mains may then start to crack again and things like that. So it's not as simple as just reducing pressure is going to solve absolutely everything. We are finding, though, even within our highly optimised systems, and I said, we started doing DMAs back in the 80s, we're still dividing them down and getting smaller DMA areas. Pressure calming, stopping those transients going through the network is extremely important. Less so if you've got a fully plastic or at least a PE system, still relevant if you've got PVC. But pressure calming is increasingly becoming important. We're starting to recognise how many pressure waves go through our network. I did a research project recently with UKWIR that looked at the causes and effects of transients going through. We found that our networks are really, really noisy. Loads of pressure waves going up and down our system. And what happens is those pressure waves simply move through until they find a weak point, and you've got a burst. So calming is really important as well. Keep your systems as calm as possible. We know that about 40% of those pressure transients don't come from pumps going on and off. It's ball valves slamming shut inside large properties and things like that. It's network operations where you're opening up a valve or a hydrant that are causing pressure waves to go up and down the system. When you talk with water companies, they'll tell you that the quietest day for leaks tends to be Christmas Day. And the reason for that is because that's the least amount of network operations. Okay, awareness. Most awareness solutions in the UK depend upon DMA monitoring. Okay, monitoring these small areas and trying to understand what's going on with them. In my company, most of our DMAs are a single feed, but a number of water companies have multi-feed DMAs. Now, multi-feeds are useful in the sense that if you have a burst upon one of your entries to a DMA, you've still got another one way of supplying water. However, for managing leakage, they are a bit of a nightmare. Because if you've got 2 meters coming in and one goes down, effectively you're blind. I know some companies that have got 6 or even 7 meters feeding a DMA. And as soon as one of those has a problem, effectively you don't know what's going on within that area. So multi-feed DMA is less than optimal. In the UK, the standard data granularity is 15-minute data. So we sample every 15 minutes and we bring it back every hour. The reason for that is because of the old loggers we used to have. When I entered this industry, I would go out installing loggers in the field. I would go out and I'd find a hydrant, I'd put a pressure cap on a hydrant with a fitting on it, and I would take my logger, which I programmed up in the office, because we didn't have laptops, and I would plug it in, and I would leave it there for 2 weeks, and then I'd come back 2 weeks later and unplug it. And that logger that I had to carry around in the car with a battery only had a certain amount of data capability. As a result, the whole industry standardised back then in the 80s on 15-minute data. Unfortunately, even with all the modern data sets coming through, the modern capabilities, we still run on that 15-minute data. So what we find is that makes finding leaks during the day very challenging. When you're looking at 15-minute data, when you're looking at consumption actually occurring at the same time, it's nigh on impossible to find a leak in that data. So that's why companies use that night line. The only way they're going to be aware of a leak breaking out is by looking at 3 o'clock in the morning and saying, has the area gone up then? Because during the day, the signal to noise ratio is too difficult. We've been moving to higher data rates. So within my company, we've actually moved to 1 minute data every 15 minutes. And when we did that, we actually found that we could do DMA predictions during the day. So what that's actually led to is within SES, we now actually have a 2-hour awareness time. So rather than having to wait for that night line, we now know roughly within 2 hours of a leak breaking out. And that could be a hidden leak under the surface, so no customer phoning in. Just to give you an example of what that actually means is I talk about night line and using a night line. Typically for awareness, it's 3 days. So let's imagine a hidden leak has broken out just outside the building here, on the pipe outside there. Nothing showing on the surface, and it's not affecting your water supply in here to the degree that you notice. What will happen is the local water company will see that go up. They'll see the DMA go up. So that if it went today, they're not going to see that until tomorrow at 3 o'clock in the morning. And then they're going to come in and they're going to look at their data and go, oh, look, that DMA's gone up. But you know what? It could be this place filling a tank. There could be some reason for legitimate use being used at 3 o'clock in the morning. You may be running experiments at that time. You're going, no, that's exactly, and it's not going to happen the next night. So therefore, no company will go in on a one-night jump. Almost inevitably, they leave it for 2 nights. So it will not be until the 3rd day that they'll actually send anybody to investigate and start looking in that area. So the jump from 3 days to 2 hours has made a huge difference in terms of our awareness time. There's a number of solutions now that use AI, looking at existing burst records and mains and saying, okay, where do we think it's most likely to go? If I'm going to be sending people into an area, where do we start looking? What are the most likely mains to burst? And what's really interesting is actually that awareness tool is becoming increasingly an operational tool. One of the things that we're struggling with in the UK at the moment is what we call mass breakouts. One of the things I talk about is 3-mode breakout. We say that bursts occur primarily because of those pressure waves going down the pipe, finding a weak point and popping it. But we also see it in a winter breakout as well, a freeze-thaw event, where effectively the ground heaves. It's a one-off event. You come in one morning, it's been 3 or 4 days of heavy frost. As a leakage manager, it's a horrible feeling because you come in that morning and suddenly half your DMAs have jumped as a result of bursts. But it is a one-off event that just happens on that thaw. The other one we're seeing, even more concerning, is climate change with soil dry out in the summers. The last 3 years, we've seen soil dry out and wet out in the summers, and that causes certain soil types to move massively. The peats around here, the clays in my area, massive ground movements underground. And as a result of that, you get a mass breakout of bursts. One of the predictions I'm making at the moment is that is probably to become one of the most prevalent causes of leakage in the UK with these mass breakouts. That's why awareness tools are going to be increasingly important, because when you have a mass breakout like that, the awareness tools tells you where to start looking and enables you to get ahead of the game. One of my neighbouring water companies actually ran out of water from one of their water towers, one of their reservoirs, as a result of a mass breakout, and it meant that thousands of customers were out of water for 4 days. The reason why I tell you it's a neighbour is because we had exactly the same weather conditions, but we had our smart network up and running. And during that same period of time, we lost supply to 48 customers for just over 3.5 hours. That's the difference good awareness can make. So the awareness tool is not just leakage, it's an operational tool. Location. Many companies have got really well-developed acoustic networks for finding these leaks. But it's complex. You have loads and loads of loggers. So Birmingham has 20 to 30,000 acoustic loggers spread throughout the city centre there. The analysis of that is complex. That's a lot of data points to look at. And in addition, because the sound doesn't carry too far down the mains, you're going to need loads and loads of sensors in order to do that. So although acoustics remains a well-developed system, companies are looking around for alternatives and going, how else can I locate leaks without having to put loads and loads of sensors out? Anglian really pioneered the use of hydrophones. When we talk about acoustics, we're typically talking about accelerometers. So these are devices a bit smaller than that, and they will sit on top of valves and things like that, and they're picking up the vibration of the valve. A hydrophone, by difference, actually goes touching the water column. So the sensor is in contact with the water and therefore gets a better signal. As a result, you need fewer sensors within your network. So hydrophones, and they're particularly good at locating leaks on plastic because it doesn't attenuate the sound so much. Number of non-acoustic techniques being developed, so satellites. Fibre optics using what's called dark fibre. This is where your cable company has gone down the road, they've laid fibre network down the road. We can actually use that fibre network and we can use the vibrations of a leak causing a vibration in that fibre network. We can actually use that sound, that vibration, and we can localise the leak coming back from that as well. Water conductivity and temperature and water quality monitoring, all other methods that we're looking at to say, how can we localise these leaks better? A number of companies have been using satellite technology, variety of results on that one. And fibre optic, as I said, I think that's some of the most interesting areas because we don't have to deploy sensors. Typically, there's already dark fibre down those roads. It's just a question of how we hook into that dark fibre and start to use that. Seeing some really interesting trials in that area. Micro pressure variation. That's one that my company's been working on and developed quite a bit. So this is saying, okay, when a burst occurs, what it will do is it'll actually drop the pressure locally around that burst. Can we detect that pressure drop and react to that? Now, there's a beauty about using micro pressure variation. With acoustics, it's really hard to tell from the sound what kind of burst it is. The big bursts actually tend to make the least sound. Where a pipe is fractured like that and is running full bore open, there's very little noise coming out from it. With micro pressure variation, the size of the burst will directly affect the amount of pressure that we're seeing. And so what we've been doing is deploying a number of sensors within an area, typically about 5 to 7 sensors. Say, okay, let's measure the pressure and look for small changes in that pressure and what that can tell us. One of the areas, we're running this in about 10% of our area as a trial, and we were going out and opening up valves in order to try and simulate a leak and test it out. And then, I won't say fortunately, because I don't like bursts, but we had a burst within one of the areas where we're trialling this. Now you can see the burst actually occurring here. So here's our normal daily pattern, and here you can see there's a jump there. That's the burst breaking out, and that's the repair. So the area that it was in, Edenbridge, a small town just south of London, 881 properties in the DMA there, and about 12 kilometres of main. So what actually happened was this. At 8:30, 1 hour before the burst occurs, we are monitoring pressure. So we have the flow coming into the DMA over here, and we are monitoring pressure around the DMA at these points here. The red dots tell me that there is medium pressure loss occurring. Now that's expected. It is 8:30 in the morning. That's peak time. Everybody getting up, running showers, having breakfast, getting the kids out the door to school, all of those things. Lots of water use taking place, so I would expect to see a drop in pressure at that time. But you'll notice that none of them are saying it's a high pressure drop. These are all medium pressure drops. It's expected, and the system didn't alert on that. 8:30, 1 hour before the burst occurs. 45 minutes after that burst has occurred, you can see the change straight away. I now have high pressure loss in the area. No customer has phoned in. Nobody has reported it, but our system picked it up and had alerted by this stage to say there's something going on. And you can see that concentration of black spots over on the right-hand side. And as we zoom in, you can actually see there's loads of low pressure alerts coming in around that area. And you can see actually where we located the burst when we sent an inspector out to find it. A hidden burst, nothing showing on the surface. The beauty of that one, therefore, is this. That leak occurred at 9:30 in the morning, peak time. Hardest time to locate a leak because everything else is going on at the same time. Our burst find system reacted within 45 minutes and localised it down to a street level. Interesting enough, the DMA alert system, and that one uses a flow profile and says a learned flow profile using AI, that alerted within an hour and a quarter, 75 minutes, so that was later. We got the leak fixed by 4:30 that afternoon. Now that's really impressive. No effect upon customers in terms of going out of supply or anything like that until we actually just went out and did that leak repair. That's the kind of system that makes a massive difference in terms of driving down your leakage. Once a leak has occurred, the clock is running. The longer you leave that leak running, the more water you're going to lose. So awareness, location, and mend need to be as fast as you can possibly make it. Okay, leads on to the final bit. Leakage innovation heat map is mend. Yes. As I said, very little development work on mend. It's the area with the greatest spend, 52%. Typically, as I said, this is because the repairs aren't carried out by the leakage team, it's outsourced. And unfortunately, if you're a contractor, what happens is you win the contract and say, right, that's fantastic, I've won the contract to do the main repairs for a certain water company. What's the first thing you do is you go out and get some JCBs because you're going to need a lot of JCBs. And you're hiring these JCBs, okay? They're owned by another company, you hire them and they sit in your yard. But while they're sitting in your yard, they are not earning you money. And so you want them out the yard digging holes. So if you have JCBs, everything looks like a hole. And if the water company comes along and says, I've got this amazing new method, we can repair pipes without having to dig holes, what happens to my JCBs? Now, I don't want to be unfair on contractors. They are incentivised to do that because that's how we write our contracts. Okay, that's what they bid for. What we've got to do is come up with different ways of managing our contractual arrangements to incentivise the right behaviour. Most repairs we know are carried out quickly. There's a proportion that takes significantly longer, weeks, months, in some cases even years. And the reason for that will be is it's not a big leak, and the cost of actually repairing it is so disproportionate to the actual cost of water that's going out through that leak that companies will say, do you know what, it's not worth going in until that is a problem, until it's showing on the surface, until it's causing a disruption to our customers. How do we deal with these ones? As I said, most contractors have little incentive for low dig and no dig methods. Let's just talk about low dig. Low dig is the idea of keyhole surgery. When I describe it, I always say I would like to be able to repair a pipe through a piece of A4 paper. Imagine laying that down on the ground, be able to dig down and then carry out a repair and then reinstate through a small hole. It has a number of advantages. It's less disruption. It's far more acceptable to the councils for you to come in and do some work like that as well. So we're looking at low dig methodologies as well. One of the rises of things we're seeing is sealants. So there's a number of companies that have developed sealant solutions. We're starting to use those on small diameters, so typically supply and com pipes. But actually this is like rad weld. Rad weld for pipes, where you literally inject this solution down, it's going through, it's finding the leak, and then it's sealing the leak at that point. Now to me that's a brilliant solution. I really love that idea that we can seal. We don't know the longevity of these. The ones that we've done have been about 3 years old and they seem to be holding up absolutely fine. But you know what? To me, actually, longevity isn't the main issue. I'm very, very happy with the idea of temporary repairs. And I'll tell you why. Because you're thinking, no, hang on, everything should be permanent. If you cut your arm, you've cut your arm and it's a nasty bleed and you're going to have to go to the hospital to get it repaired, to get it fixed. Do you leave it going full flow? Just let it bleed out on the way to the hospital? No, the first thing you're going to do is you put a temporary repair on, you put a clamp on, you put a plaster, you put a bandage on, anything to stop that fluid getting out, because blood is valuable. And you don't want it leaking out until you can do a full and proper repair. Think about water in the same way. If water is valuable to us, a temporary repair where we can reduce that flow rate until such time as we can do a full repair is important and is valuable to us. So don't rule out the idea of temporary repairs. They are equally valuable for water companies as well, if we can start to get those in. We're seeing things like interlocking clamps as well. One of the issues we get is when a pipe splits. So when you get a split, it's really hard because you end up cutting out an entire section of pipe. You therefore have a long hole, and all of the bits you've got to take out an entire length. So one of the things that we've all started using in the UK is now interlocking clamps, where you can actually put them together in a line of these clamps and use them to fix splits and things like that. And we're now looking at specialised teams to deal with difficult bursts and adopting new technologies, the idea of what I call special leak services, whereby what we can actually do is say, okay, look, let's look at those really difficult to mend bursts, those ones that take weeks and days, and weeks and in months and possibly even years. And say, actually, why don't we split those off and get specialist teams to deal with them, because it's a different skill set to repair those. These teams can dig up if need be, but actually, these are the teams that will adopt all of the new technologies coming through. So if a supplier is going, I've got a brand new bit of kit, who do I take it to? Do I take it to the contractors? They're not really incentivised. Do I take it to the water company? But they're not the ones that are actually doing the work. Special leak services will be the teams where they can go, right, let me bring it to you. Because these will be the teams that will be willing to try out new and different techniques to carry out fixes on these mains. My personal belief is mend is the next big thing that we've got to solve. We're seeing loads and loads of solutions so far on awareness and location. As I said, about 70% of research is in that area. And most of the companies I talk to say there's no dearth of solutions there. There's a lot of stuff going on in those areas. It's just a question of us evaluating and adopting and rolling out what are the best techniques and solutions there. Now, that's not to say there won't be disruptors that come through in that area, but they'll be rarer because they've got to overcome the hurdle that companies already have techniques in that area. Prevent, yes, certainly there are some areas in prevent. It's less well developed. So we will see more pressure management, calming. We will see better techniques coming through in terms of mains laying and things like that. But the area I think is most productive at the moment is going to be that mend one, because you look at it and go, actually at the moment, typically on average, 4 or 5 days to carry out that repair. What if we can shave 2 days off that by simply organising ourselves better, by bringing in better techniques and tools, so the leaks that last for so long, because we can't get there because it's right by some traffic lights, or there's another contractor working in that road at the moment, it's too deep and we can't get on it easily. If we can come up with better ways of dealing with those, that's going to have a huge advantage in terms of driving down leakage. I'm going to pause there. I think that's basically me for the moment, and I will put up any questions. Sorry, I've talked for 40 minutes or so.
Thank you very much for your So we have got time for a few questions. I'm not sure if there is a lecture in this room at 12:30 or not, so we'll continue until we'll see if they are asking us to
Until we
leave
get
the
thrown
room.
out,
Yeah,
yeah.
exactly. So, any questions? Yes. Rashid, yeah.
Yeah, thanks for the great presentation. I have a couple of questions. One is, moving forward, the main goal is to bridge the gap between supply and demand. In the coming decade, where do you see the investments going towards? Like either the smart infrastructure, in terms of the smart meters, or digital solutions, or asset management?
No, really good question. And when you look at that, it's got to be all three. And that's the point that effectively, when you look at the National Infrastructure Commission, they came back and went, okay, you've got to be able to do all three of those. Now, when you look at the costs in terms of doing those, building new reservoirs, hugely expensive. Okay, that's massive. And the huge great mains that they're going to have to lay as well. Those are really expensive, capitally intensive projects. You look at smart metering, that's lots and lots of small bits of kit. It's a rollout in terms of doing that. But actually, relatively, I'm not going to say straightforward, but what you're doing is replacing generally existing meters with smart meters coming through. The bit with smart metering is a lot more about the change for your customers and how you manage your customer side. Leakage, as I said, it's got to be a number of different areas, so there's going to be a spread behind that. The problem that we've got is you can't solve that supply-demand gap by just one of those. And that's the big issue for us, is I hate to be in a situation where I turn round in 25 years' time and we've built all the infrastructure, all the reservoirs are working and all the transfers are working, every customer has got a smart meter and understands and has dropped their consumption, and suddenly the great big focus comes down upon leakage and says, why didn't you achieve what you set out to achieve? So when you look at the cost side and that side of it, I think, yes, certainly the big capital projects are going to be more expensive, but they are not going to solve the supply-demand gap. It's got to be all of those projects working together. And when I look at the leakage aspect, that's probably one of the most complex because, as I said before, there's no silver bullet. There's no one solution that we can put in. You can build reservoirs. We've done that plenty of times before and we know how to do that. We can build large transfer systems. We know how to do that. We know how to do smart metering and roll those out. Leakage, there's so many more unknowns in there in terms of how we're going to drive it down. And the fact that every company is struggling at the moment and a number are failing shows you how difficult that's going to be.
Thank you.
You had a second question, go on.
I think,
Since you're speaking already.
That actually answered the
Right,
second question
good.
as well.
Okay. Yeah,
Yes, thank you very much for the great presentation. My question is about, you showed us a figure about the POM system and the going research on that, and number 29 is about calculating whole life costing and the total value of main renewal.
Yeah.
So, most of the water companies in the UK are not transparent about the replacement of the pipes. For example, if we consider that it's 2% of the length of the network for each year, so it took about something like 50 years to renew whole the network.
Yeah.
The question is, you said that most of the time we recognize that the cast iron pipes are working better than ductile iron. So let's say if you're going to replace pipes, and I know that the 100 kilometers of the pipes replacement is a huge project for a water company. Are you sure that which material type you're going to use for the replacements?
A really good point. So, okay, let's firstly start with which material am I replacing, okay,
Yeah.
before what I'm going to replace it with. Okay, so which material do I use for my replacement program? Which materials am I going to be replacing? There is a lot to do in terms of asset condition. The difference that we've got is that every company is starting from a different point. If you look at the different water companies, and that chart I showed you with different leakage levels in different companies, there's a wide discrepancy in terms of how much cast iron we still have within our areas because of different historical replacement programs. Some of the companies have gone a long way to ripping out cast iron. So they've got a lot more plastic, they've got a lot more PVC in their areas as a result of that, and that really helps them. Other companies have lagged back. So my own company, we were actually laying ductile iron up until probably about 20 years ago when we actually made the switch then. We were very late coming to plastic, and in fact we hardly ever laid PVC. We made a decision not to do that. So all of the water companies actually have a different starting point, and then understanding the condition as well, because the condition is not as simple as saying it's cast iron, it'll be in poor condition. A lot of that would depend upon the soil types around it and things like that. With PVC, it would depend upon how well supervised the teams were. And with PE, exactly the same. Supervision is a huge issue in terms of how well that pipe will be able to last and how long it will last for, because typically with PE, it's the joints that go, it's not the material. So it's difficult on that side, and therefore companies, I'm not going to say they hide those figures, but actually calculating your asset base and having a really good understanding of what's the current condition and what it's deteriorating at and what it's going to be like in 25 years is really, really hard to do, particularly because it's buried 1 metre below the ground. One of the reasons why we're spending an awful lot of money doing our sound system going down the pipes is to try and gain that understanding. The only other company in the world that's got anything like that kind of data, as I understand it, is Singapore Water, because they've got a similar thing trying to do that. So that's number one, is really hard to understand your asset condition. Number two is what do you replace it with? And again, that comes down to companies and their different policies as well. So a lot of it will be on what you've already got in the ground. So let's go back to my company. We have very, very little PVC in my area. As a result, we don't have a lot of PVC repair materials. We don't keep them because it's rare for us to have a burst on PVC. So because we're not carrying a lot of repair materials for PVC, it's really unlikely that I'm going to start installing PVC, because I then have to change all of my repair side and all of my techniques in order to take that on board. So it's likely I'm going to remain with PE. But I talk with neighbouring companies and they're going, no, we laid PVC all the way through the 70s, 80s and 90s. We've got loads of repair materials, and actually we understand PVC really well, so we're quite happy to lay that. So each company will look at their own existing base, but a lot of it is about what stock of materials they've got and also the expertise they've got with those materials in terms of laying them as well. So unfortunately, the simple point is every company acts as an individual company in terms of how they manage that risk, in terms of how they manage the materials going in. Thank you very much.
But what is the average replacement currently in UK? It's not 2%.
Yeah, it is less than that. It's very less than that.
So I'm slightly going to turn away from camera at this point. The average replacement rate in the UK is about 0.2%. 0.2%.
Yes, not 4%, yeah.
It's really bad. And part of the reason behind that is because it is hard for us to justify mains replacement on leakage purposes if there's other ways of bringing down leakage. So there's a really good Water UK report that looked at this and said, okay, how do we drive down leakage? How do we halve leakage? And said, what's the methodologies that we go through? And they said, okay, look, you obviously start with the most cost-effective first, okay? And the most cost-effective methods of driving down your leakage are pressure reduction, okay, pressure management, ALC, feet on the ground and things like that. So you start with getting that optimised, get that right first. If you're not doing that at the moment, those are the areas that you start with because that's most cost effective. And then you start to move into things like smart metering and smart networks, and you start to put those out. That's what my company's been doing. So we're doing that kind of pressure management with our DMA Asset Health, and then we're moving into smart metering. We're rolling that out now, and we're doing smart networks. Finally, once you've done all of those, and you've almost, I won't say exhausted all the possibilities from them, but you've got those well established, then and only then do you start to find that mains replacement programs are your only other way of driving down that leakage, even though they are more expensive. So with my company, I know for this current AMP, we are still going to be using deployment, outgoing awareness and location tools and pressure management and all those, because we're still doing those. I know that next AMP we're going to be looking at a lot more mains replacement because that will be the only tool left in the box for us. So that's why you're seeing this kind of discrepancy in terms of our replacement rates. When you look internationally, other countries have massive differently replacement rates. I was in Germany recently and I was with a German water company, I said, how much cast iron have you got in the ground? They went, cast iron? We have no cast iron. I won't even try doing the accent. But they said, we have no cast iron, we took that all out years ago, which is fantastic. But I know from the material science work that I've done that they would have replaced extremely good cast iron. There was probably years and years of life still in it, and their customers would have paid for that, even though that cast iron was actually still in good condition. So it's not as simple as saying, yes, you rip everything out and such like. If it's in good condition, get the best life out of that asset that you can, and that's about understanding asset conditions and things like that. You will see replacement rates go up in the UK. They will have to go up, but what you'll see is water companies using all the other methodologies first before they get to those. And that's because we're driven by a financial regulator who's saying this has to be cost effective for our customers. One of the reasons why the Germans were able to do it so cheaply as well is, I told you that figure for replacing 1 mile of main in London. When I talked with the Germans, I said, how do you deal with the traffic management and digging up the road and all the other things like that? And they went, it's our city. You see, in Germany, the municipality owns the water company as well. It's all the same organisation. So when they want to dig up the road, they simply walk next door to the department that does the roads and say, we're going to come down this road and dig it up. Yeah, that's fine, absolutely. Put it back as you found it, please. And that's literally it. It's a far simpler process because they own everything, and that makes it far easier to do. Whereas in the UK,